Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Rockingham by Damo89. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and 3x3 box. We have a mid loop, where we need to draw a single one-cell wide loop of orthogonally connected cells into the grid that does not branch or enter any cell more than once. The loop must pass through all given dots, and all given dots must be in the middle of a straight loop segment. The distance from a dot to the next turn on the loop must be identical in both directions. Oh, interesting. So the loop has to go through the entire, all the dots in this grid. And so say we had the loop go this way. Oops. Say we had the loop go this way. Then it would have to, it could not, the distance from the dot to the next turn on along the loop must be identical in both directions. So if it turns here, it must turn here in this distance away from the dot. And that's in the mid loop again. The loop must pass through all given dots. It does not branch or enter any cell more than once. So it can touch itself, but it cannot branch. So keep that in mind. It can't do something like that. That's not allowed. We also have ambiguous Kropki, where digits separated by a gray dot are consecutive or one is double the other. Adjacent digits on the loop not separated by a dot must not be consecutive or where one is double the other. So that means these digits have to be either in a 1 to 2 ratio or they have to be consecutive. So if this were, well, let's use, that's not good either. Let's use this. If this digit were a 4, then this digit could be 2 or 8, because it's either in a 1 to 2 ratio, or this is 3 or 5, because these would have to be consecutive. But say the loop continued on this way. The problem, then these two digits could not be consecutive, and they can't also be in a 1 to 2 ratio if there is no dot between them on the loop. And those are all the rules. If so, that's a negative constraint specifically for those digits on the loop. If they don't have a dot between them, they cannot be consecutive and they cannot be in a 1 to 2 ratio. Well, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, this loop has to go, these go here. They must turn that way, so this must turn that way also. That means it cannot go here because the problem is that it would branch. So this must continue on there. This must continue on there. So then this has to go through here because otherwise it would be branching if it goes there and it goes through here. This is going there and there. This must be 3 cells and then turning. Cannot turn into here because then that would be a very small loop. So it must turn there. This has the same thing. It turns here, so this must turn there. This cannot close there because that would be loop, so this has to go that way. So that's 3 going that way, and then it's turning. This then has to go here because it cannot go straight here because then that would branch. These are turning once here, so that must turn again. This must turn here. It continues there. It has to have there. We have to have there, 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 here, and here. Okay. So this is the loop we're on. Hmm. This has to turn. So that means this has to turn. This has to turn. So that means this has to turn that way. So if we connect to here, that means it goes that way, that way. But then it has to connect that way, and then this doesn't work. So this cannot connect here. So this must connect to this way, which means this goes there. This has to go there to turn correctly. This cannot connect to here because if it did, then this doesn't have anywhere to go without branching. This could connect here. That is potentially possible. This cannot connect to this because if it did, this has to go 1, 2, 3 before it turns. So this cannot go straight there. That means this can't go straight here. This must turn in either this direction or this way. That means this can't turn here, so this must go straight here. So we have to turn there and then turn there. Because again, if we try turning here, then it has to go to here and then turn, but that can't turn because it would be part of this loop. This cannot go here. So this is turning either here. Well, so this has to turn either here or here. So it's connecting to either, is that guaranteed? I don't know. How else do we connect? This cannot connect that way because then this doesn't have anything to connect with. So this has to connect there. Okay, so that's good to know. That means this can't turn that way. If it does, then it doesn't have anywhere to go, so it must connect that way. These cannot connect because if they did, then this would be a closed loop and it would not go through the rest of the dots. And it can't go this way because then this would be 3 here and 2 in this direction, and then they would not have, the dot would not be equal loop segments away from the turns. So this has to go that way. This then can't go here and connect, so this must turn that way. Okay. This cannot connect to here. If it did, that would be 1, 2, 3 away from the dot. So 1, 2, 3 would mean this is branching. So this has to turn, which means this is turning here, and this must turn again. So we can't turn here because then it doesn't connect to any cell in the loop. Same with this. So this must be turning here and here. Okay. Can we connect to here? Then that would be 1, 2, 3, 4, which doesn't work there because this would be only 3 cells away from the dot. So this has to go that way. This cannot connect to here, so it must go that way. That means it connects there. This has to go here because this loop can only go, has to have the same turnings from the dot here. We could go 3 here, but if we go 3 here, it connects either this way, in which case this part doesn't connect to anything. So this cannot, or it connects to here, and you have the same problem, right? Then this part doesn't connect to anything in the loop. So you cannot connect to here, which means this is turning here or here. This must turn there. I forgot to say what orthogonally connected cells are. Anyways, this is turning once here or once here. This cannot go this way. It has to, so, yeah. Can this connect this way is the question. Then it would turn there. That's fine. What about here? If it connects that way, this has to go that way. That's fine too. Okay. I'm trying to figure out if you can construct the loop entirely this way. We know... Can you go that way? Huh. Okay. Yeah, I don't know how much more we can get from this. I think we have to actually start filling in numbers. Okay, remaining digits in column 8. We have 1, 2, 4, 5, 7, 8. No 2 here, obviously, because 2 in the row. This can't be 1. 1 would only be in consecutive or in a 1 to 2 ratio with 2, and we don't have a 2 available there. No 4, 7, 5 there. No 5 here. And we don't have anything else here. Okay, so 4 could be with 8. Or 3 or 5, but it can't be 3 here or 5 here because of 3 or 5 and 3 in the box and 5 in the column. 5 would have to be with 4 or 6. 7 would have to be with 6 or 8. 8 would have to be with 4 or 7 here. So those are the possibilities. Here, 1 could be with 2 only. 2 could be with 1, 3, or 4, but there's no 4 available here. 8 could not be with 4, cannot be with 7, so 8 would have to be with 9 there. This cannot be 5 or 7. We can't have 5 here anyways, because that's consecutive with 6. But 1, 2, 4, 8 is fine. These digits cannot contain 6 or 8. So if they're in a 1 to 2 ratio, it's 2 with 1 or 4. If they're consecutive, the even digit has to be 2 or 4. So then this is 3, 4, 5. So we cannot have 4 here. You could have a 2, 4 pair here too, though, so that's fine. This digit cannot be... Could be 2, 3, 5, 6, or 9. 2 would be in a 1 to 2 ratio with 4. 3 and 5 would be consecutive with 4. So it has to be 6 or 9, but 9 is not possible to be here because 9 would have to be consecutive with 8 only. And 8 is already in the column. So this is guaranteed to be 6. 6 is in a 1 to 2 ratio with 3, but this can't be 3 because of 3 in the row. So this must be 5 or 7 here, which means this digit has to be consecutive with 5 or 7. So that's 4, 6, or 8 there. Okay. If it's 1 to 2 ratio, it cannot be 8, 4 or 3, 6. So it would have to be 2, 1 if that were the case. Otherwise, it's consecutive, and it would be 2 with 1 or 3, or 8 with 9. So those are the only possibilities. Interesting. So then we have a 1, 2... We need a 5 somewhere in this row. Cannot be here. So 5 would have to be here. Can't be on these Kropke dots because 5 is only consecutive with 4 and 6, and can't be here because of 5 in the box. So this is 5. These digits cannot be consecutive with it, so it has to be 8. So this is 8, which is only consecutive with 7 here. So this is 5, that's 6. That means this is what? 1, 2, 3, 8, or 9. Which doesn't have any relationship with 5, which is good. 1 would force this to be 2. 2 would make this 1. 2 could be with 1 or 4. Or 3. But it cannot be 3 here because of 3 in the box. 3 could be with 2 or 4. Or 6. 8, 9 cannot be here. Because if 9 is here, this would have to be 8. 8 could be here with 9. No, it can't be 9. So this has to be 1, 2, or 3 here. Because 8 would have to have 7 or... Oh, it could be 4. Never mind. So this could be 8 and 4. So that could work. Never mind. We know, though, 9 has to be with 8 in one of these pairs of cells here. So this cannot be 8 then. Okay, well, there we go. 2 has to be either with 1 and 3, so this cannot be 2. So we have 1 here, which would force this to be 2, or 3 here, which means it could be 2, 4, or 6 there. So that's possible. We have 8 and 9, 8 and 9 as possibilities. That's going to work for everything. So remaining digits in box 4, we have 1, 2, 3, 7, 8, and 9. So no 1, 7, 8 here, no 1, 7, 8 here. No 8 here, no 8 here. 8 cannot be here because these are next to each other on the line, and they do not have a dot between them. So 8 has to be here. Interesting. 2 can't be here. 3 can't be here because that would be consecutive with the... That would be in a 1 to 2 ratio or consecutive with the 4. This cannot be a 2-3 pair because then they would be consecutive and there's no dot between them. So they have to have a 9 here, which eliminates 9 in the rest of the box. If this were 1, that would mean this has to be 2. If this is 2, it could be 1, 3, or 4. 3 cannot be 6, so it would be 2 or 4 here because of 6 in the row. 7 would have to be 6 or 8, but this can't be 7 then. So this is interesting. It's 1, 2, 3, or 4 there. So 7 is going to have to be one of these two digits here. Because 7 only can be consecutive with 6 or 8, and that's it. This can't be 4. That's in a 1 to 2 ratio with 8. So we know this has to be a 2 with 1 or 3 being on the other side. This cannot be 2 then. 2 can't be here. 2 can't be here. Where is the 2 in box 1? It must be here, which eliminates 2 from being here. This is 1, 3, or 5, which must be with an even digit because 1, 3, and 5 are not consecutive with each other, and they are not in a 1 to 2 ratio with another odd digit. So this is 2 or 4 here. 4 can't be here, so 4 is one of these 3 digits. What digits can be here? Cannot be 2. We could have no 1. It could be 3, 4, no 5, 6, no 7. 8 or 9. It cannot be 8, and 9 would force that to have an 8 next to it. So this has to be either 3, 4 or 3, 6. 2 cannot be here because that would be consecutive with a 1. So 2 has to be here, which means this cannot be 2. So this can no longer be 1 here because 1 is guaranteed just to have to be next to a 2 if there's a dot between them. So this is 3. That eliminates 3 in the rest of the row. 3 is consecutive with 4, and it's in a 1 to 2 ratio with 6. This has to also be 3 for the same reasoning, because 3 is consecutive with 4 and in a 1 to 2 ratio with 6. So that eliminates 3 in the rest of the column. So this is 1, 2 as a pair, which means this can't be 1 or 2. It's 7, which makes that 1. 1 eliminates 1 here, so it's 2 and 1 there. These can't be 2 because of the 2 in the box, so this is a 3, 9 pair. Remaining digits in column 2. Actually, let's do remaining digits in column 1 first. No 3, it could be 4, 6, or 9 there. In column 2, we have 2, 4, and 5. No 2 here because of 2 in the row. This is 4 or 5. This can't be 4 because that's in a 1 to 2 ratio with 8, but there's no dot between them, so this is 2 or 5 there. 1 eliminates 1 here, so this is 3 or 5 there. These are in some sort of relationship. Digits, where is the 9 in box 1? Can't be here because of 9 in the row, so 9 has to be here. That leaves this as 4, 5. It can't be 4. No 1, no 2, no 3. So this is 5 or 6 here. 5 would have to be in a 1, would be consecutive with 4 or 6. 6 could be with 5 or 7, or in a 1 to 2 ratio with 3. So those all kind of work. Hmm. Uh, hmm. Um. Hmm. This is 1, so this cannot be 1 here. There's no 2 or 8 here because of 2 or 8 in the row. So this is 1 or 4. That's interesting. This digit cannot be 6. So where is 6 in this box? Can't be here, can't be here. This can't be 6 because it's consecutive with 5 and there's no dot between them. 6, this can't be 7 because of 7 in the row. So 6 is not consecutive with that digit here. And it's not in a 1 to 2 ratio because we have a 3 already in the box. So the 6 has to be here. This can't be 7. Where is 7 in the box then? It has to be here. So that means one of these is a 9. So we're guaranteed 9 with 8. Remaining digits in this box are 1, 2, 4, 8, 9. Obviously no 1 here. This cannot be 8 because the 9 has to be consecutive with the 8 from one of these digits. So this cannot be 8, which means 8 is one of these two digits here, which eliminates 8 in the rest of the column, so this can't be 8 here. 8 can't be here for the same reasoning. 7 eliminates 7 here. Okay. 4 and 8 is possible. 5 and 6 is possible. So 4, you cannot have a 4 here. That would force this to be 5. And that would eliminate all possibilities for that cell. So you could have 4 and 8 here. 5 and 6, 5 and 7 and 6, or 7 and 8. And those are all possible. Remaining digits of row 3, we have 1, 4, 5, 6, and 9 available. No 9 or 6 here because of 9 in the box and 6 in the column. Okay. Where is this digit? Cannot be 3, 5, or 7, or 9. So it's 1, 2, 4, 6, 8. No 1. This is 2, 4, 6, 8 here. Interesting. So these are all even digits, interestingly enough. Remaining digits here have to be 1 and 9. And then 1 out of 2, 4, 6, 8. No 6 here, though. So 1 and 9 are here. That means 1 cannot be here. Where is 1 in column 8? It has to be one of these two digits here, which means this can't be 1. So since that can't be 1, this can't be 2, correspondingly. These digits are in some relationship. If you have 2 here, it could be 1, 3, and 4. If it's 4, it's 2, 8, 3, or 5. If it's 5, it would have to be 4 here, not 6. If it's 7 here, it would have to be 8, not 6. So those are those. Interesting. Okay. This can't be 1 because we are guaranteed a 1 or 9 here. This can't be 4. If this is 4, that makes this 6, which makes that 8. And 4 and 8 are in a 1 to 2 ratio without a dot between them. 8 cannot be here either. If this is 8, that's 6, which makes that 4. And 8 and 4 are in a 1 to 2 ratio with each other. 6, 2, and 8 does work. 6, 4, and 8 also works. We have to have 8 somewhere here. 8 cannot be here because that would be consecutive with the 9. So 8 in box 3 has to be one of those 2 digits, which means 8 in row 2 has to be one of these 2 digits. Interesting. 2 in row 2 has to be one of these 2 digits. No 1 here because of 1 in the row. So if this is guaranteed to have a 1 here. You cannot have a 2 here because that would be consecutive with the 1 guaranteed. So therefore this cannot be 2, and there's no gray dot between them. Three is consecutive with 2, so this can't be 3. Therefore, this is 9. That makes that 3. That's interesting. Remaining digits of row 5. We have 2, 4, 6, 8, and 9. Interesting. 2 cannot be here because of 2 in the column. Remaining digits of row 6 are 1, 3, 4, and 5. 5 cannot be here because that would be consecutive with 6. 3 can't be here because that would be in a 1 to 2 ratio with 6. We have a 1, 4, 1, 4 pair in row 6, which eliminates 1, 4 in the rest of the row. So this becomes a 3, 5 pair here. Interesting. One. Where can 1 appear in row 1? Cannot be next to the 2 because there's no gray dots between them. So 1 has to be here, which means this can't be 1 here. 1 has to be one of these 3. Where's 3 in row 1? Can't be any of these digits because it would be consecutive with the 2. And there's no gray dot between them, so it has to be here. So that's 3. This can't be 3. 3 would be next to, cannot be next to 4 without a gray dot between them. So this is 5, which makes this 6, which makes that 4. 5 eliminates 5 here. 6 eliminates 6 here, so that's 2. No 2 there. This can't be 4 or 6, so it's 3, 5, or 7. That actually fits all of them. That's good. One of these is 8. We don't know which. Remaining digits of row 1. We can't have 4 there because that's in a 1 to 2 ratio with 2. So where's 4 in row 1? It has to be here. So this is 4, which makes this 8. That makes that 6. So there's no 2 or 8 here. It's 1, 4, 9 as a triplet, which eliminates 1, 4, 9. 4 eliminates 4 here, so that's 1, which means this can't be 1. That's 8 and 9. This can't be 8 or 4, so that makes that 2, which is in a 1 to 2 ratio with 4. 4 eliminates 4 here, so it's 5. No 5, 4, or 6 here, because 4 or 6 is consecutive with 5. No 5 or 6 there. It's 1, 4, or 9. 1 eliminates 1 here, so it's 4. This can't be 8, 9. It has to be 1 and 2. No 2 here. No 2 here. No 4 here. It's 6, 8, and 9. So that satisfies that. This is 6, cannot be 2 and 4. It's 5, 7 as a pair. 5 and 7 are only consecutive with other digits, which would be 4 and 8. 4 can't be here because of 4 in the column. So that's 8, which is consecutive with 7, which makes that a 5. Remaining digits in box 3 is a 3. In column, that's not working. That's 2 and 7. How did I mess that up? Oh, this can't be 3. This is 7 there. And then this is 2 and 3 as a pair, which does work. Okay, good. 7 eliminates 7 here. We have 3, 5, 8 remaining here. And this must be 6 and 7 remaining in row 1. This can't be 7 because of 7 in the column. So that's 6, that's 7. That means this can't be 6 here. Um, 6 cannot go to the 5 here. That means it either goes here or it goes there. This cannot go that way. This cannot go that way. This can't go there. Not there, not there. Hmm. 4 cannot go to the 3 or 5. Okay, this cannot be 2 and 3 because that would eliminate all possibilities for the cell. So this must be 4 with either 3 or 5 here. So this is 4. There's no 4 here. We have a 3, 5 pair in the column 2. Where's 4 in row 3? It has to be here. 4 eliminates 4 here, so that's 9. These cannot be 9. It's 1, 4 as a pair. Remaining digits. We have to have a 7 somewhere in row 7. Cannot be here, so it must be here. That leaves us as 2, 3, or 5. 2, 3, and 5 are in a relationship with 4. 2 is in a 1 to 2 ratio. 3 and 5 are consecutive, so 4 cannot go this way. Therefore, it has to go that way. Can't go here because then it can't connect to anything, so it has to connect there. That's fine. This cannot be an 8, 9 pair because that would be consecutive. So if this is 6, that would be the case. So this cannot be 6 here, which means 6 is over here. This can't be 8 because that's in a 1 to 2 ratio with 4. So this is 9, which means this can't be 9. That's 1. That makes this 8 there. 3, 5, 3, 5 as a pair. Remaining digits in column 4 are 1, 6, and 9. Remaining digits in column 3 are 3, 5, and 7. So 1 cannot be here because 1 does not have a 2 there. 3 and 6 works, 5 and 6 works, 7 and 6 works, 9 does not work. So this must be 6. So this is 6, which means this can't be 6 there. It's 1 and 9. Remaining digits in column 6. We have 2, 3, 5, and 8. No 8 here because of 8 in the row. No 5 here because of 5 in the row. Remaining digits of column 5. We have 3, 5, 8, and 9. No 5 here, no 8 here for the same reasons. 6 is consecutive with 5 or 7 in a 1 to 2 ratio with 3. 6 eliminates, this can't be 4 here. No 6 here, so this is 9. That means this can't be 4 or 9, it's 6. No 5 here because of 5 in the column, so that's 2. This can't be 2 or 5, it's 4. 4 eliminates 4 here, so that's 1 and 4 there. So 4 cannot go to the 5 because then they would be consecutive without a gray dot between them. So 4 has to go to 9, which connects with 6. You cannot turn to here because then that would go to nowhere. So this has to connect that way. Cannot connect here, so this must turn there. So this cannot be a 2-3 pair because if that were the case, then they would be consecutive without a gray dot between them. So this has to be 5, which makes this 3. That makes this 2, which makes that 3 there. Again, cannot be consecutive, so no 2 or 3 there. This has to be 8. 3 and 5 eliminate 3 and 5 here, so it's 7. No 3 or 7 there, it's 5. 5 and 9 eliminate 5 and 9 here, so it's 3. No 3 or 5 here, it's 2. So no 3 or 8 here, it's 9, which makes this 1, which makes this 9. 5 has to continue out this way. No 5 or 8 here. It's 3. That makes this 5. That makes that 8. 5 eliminates 5 here, so it's 3 and 5. So what is the path that we have to go down? Cannot connect. 6 cannot go to 3. So therefore, these must turn. So both of these have to turn then, which means it cannot connect to the 4. So then that doesn't work. 4 cannot connect with 3. 4 has to go to the 1. That means 7 and 2 connect. 8 cannot... If 8 goes... So 3 has to go here. Cannot connect with the 1 because that would form a loop. So it has to go this way, that way to connect. So therefore we connect that way. And I think that's the solution. So then this is 5. Interesting. I guess we should double check. 3 to 4 consecutive. Well, let's go this way. 3, 5, no relationship. 5, 9, no relationship. 9, 7, nothing. 7, 2, nothing. 2, 6, nothing. 6, 1, nothing. 1, 7, nothing. 7, 9, nothing. 9, 4, nothing. 4, 8, 1 to 2. 8, 2, nothing. 2, 6, nothing. 6, 3, 1 to 2. 3, 5, nothing. 5, 7, nothing. 7, 1, nothing. 1, 6, nothing. 6, 9, nothing. 9, 4, nothing. 4, 1, nothing. 1, 7, nothing. 7's consecutive with 8. 8, 2, nothing. 2, 8, nothing. 8, 3, nothing. 3 is consecutive with 2. 2, 5, nothing. 5, 7, nothing. 7, 5, nothing. 5, 3, nothing. 3, 8, nothing. 8, 3, nothing. 3, 4 is consecutive. 4, 1, nothing. 1, 6, nothing. 6, 5 is consecutive. 5, 7, nothing. 7, 2, nothing. 2, 8, nothing. 8, 1, nothing. 1 and 2 are consecutive or 1-2 ratio. 2, 9, nothing. 9, 3, nothing. 3, 7, nothing. 7, 5, nothing. 5, 8, nothing. 8, 7 is consecutive with 7 and 6 is consecutive. 6, 4, nothing. 4, 1, nothing. 1, 8, nothing. 8, 2, nothing. 2 and 1 are 1-2 ratio or consecutive. 1, 6, nothing. 6, 9, nothing. 9, 4, nothing. 4, 6, nothing. 6, 4, nothing. 4 and 2 are a 1-2 ratio. 2, 8, nothing. 8, 9 are consecutive. 9, 5, nothing. 5, 1, nothing. 1, 3, nothing. 3, 8, nothing. 8, 5, nothing. 5, 6 are consecutive. 6, 1, nothing. 1, 4, nothing. And 4 and 3 are consecutive. And that's that solve. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.